Implementing interfaces in C++ to restrict method access in derived classes. When it comes to object-oriented programming, interfaces play a crucial role in ensuring that derived classes adhere to certain contracts or sets of methods that must be implemented. In C++, interfaces can be utilized effectively to control and restrict method access in derived classes, enabling developers to design cleaner, more maintainable code. What is an interface? An interface, in the context of C++, is usually represented by a class with pure virtual functions. A pure virtual function in C++ is declared by assigning equals 0 to the function declaration. An interface doesn't actually implement any functionality, it only specifies the methods that derived classes must implement. Creating an interface in C++. In C++, creating an interface involves defining a class with pure virtual methods. Here's how you can create a simple interface. In the iExample interface, method 1 and method 2 are pure virtual functions, signified by equals 0. This means that any class derived from iExample must provide implementations for these methods. Implementing an interface in a derived class. To implement this interface in a derived class, you simply inherit from iExample and provide concrete implementations for the pure virtual functions. Here's an example of a derived class implementing the interface. In the example impl class, both method 1 and method 2 are overridden and their functionality is provided. Restricting method access. By using interfaces, you can easily control which methods a derived class must provide and ensure they stick to the expected contract. If any of the pure virtual methods from the interface are not implemented in a derived class, the compiler will throw an error, thus enforcing compliance. Moreover, interfaces also provide a way to expose only specific methods to other parts of the application. If a class inherits from an interface, other classes that interact with it through a pointer or reference to the interface can't call non-interface methods. This is particularly useful for encapsulation and controlling access. For example, conclusion. Implementing interfaces in C++ to restrict method access and enforce specific contractual obligations is a powerful technique to maintain cleaner, more modular, and easily understandable code. By defining your interfaces with pure virtual functions and ensuring that derived classes implement these methods, you can gain better control over your class design and interaction. Interfaces in C++ provide a clear and efficient way to manage method access in derived classes, promoting better coding practices and more robust application design.